I welcome you once again to this channel with a new topic in statistics known as measures of location. These measures helps us understand the relative positions of observations within a dataset. To gain a complete and clear understanding of this topic, we will study the definitions, concepts and methods of calculation supported by simple numerical illustrations. Before moving to numerical problems, it is essential to understand the basic concepts and meanings of these measures. Therefore, we shall first discuss each measures individually and then explore their applications. Measures of location indicate where a particular value lies in relations to the entire dataset. Unlike measures of central tendency, which describes the center of the data, measures of location describes the distribution and relative standards or relative standings of the data values. The most commonly used measures of location are median, quartiles, deciles, and percentiles. First is the median. We have already studied the median under the topic of measures of central tendency. As a measure of location, the median divides the data into two equal parts such that 50% of the observations lie below it and 50% lie above it. Since the median is not affected by extreme values, it is widely used in the analysis of skewed data. Before proceeding further, it is useful to briefly refresh this concept as it forms the basis for understanding other measures of location. In order to calculate these measures of locations for a raw data, a simple way is first we arrange the data in ascending or descending order, then find a midpoint which is a median, or the other three quartiles or different deciles and percentiles. We'll see for further and we'll check in upcoming examples. A simple example we'll show you here is regarding the median. If we have a data of this type and we have to find a median or any other measure of location, for median we first arrange the data. Here the data is already arranged, and the median, as you know, is a midpoint which divides the data into the two equal parts. We have the 9 observations and we use a formula of 9 plus 1 divided by 2, which is 5, and the 5 is not the median, but fifth observation of the data is the median. Here the fifth observation is 9, so the median is 9. Before we proceed other numerical examples, let's first complete this theoretical discussion of other measures of location. Here we check the first, what is quartile. Quartiles divides the data set into 4 equal parts. Although the data is divided into 4 parts, there are only 3 quartiles, namely first quartile, 25% of observations lie below it. Second quartile, 50% of observations lie below it, and this is also called the median. And third quartile, 75% of observations lie below it. Quartiles are especially useful for studying the spread and variability of the data. One more is deciles. Deciles divide the dataset into the 10 equal parts. Hence, there are 9 deciles denoted by D1 to D9. Each decile represents 10% of the data. Deciles provides a more detailed classification of data than quartiles and are commonly used in economic and demographic studies. such as income and population analysis. Percentiles. Percentiles divide the dataset into 100 equal parts. Therefore, there are 99 percentiles, denoted by P1 to P99. Sometimes we write it K percentile, kth percentile, PK. Percentiles are widely used in educational testing, competitive examinations, health and growth studies. They help compare the individual's performance with that of a large group. Measures of location are important because they provide information about the relative positions of the data values, help in understanding data distributions, are useful when the mean is not a reliable measure, play a significant role in real-life decision making, are extensively used in education, economics, health, and social sciences. Measures of location such as median, quartile, deciles, and percentiles offer a deeper insight into the structure of data. A proper understanding of these measures enables us to analyze data more effectively and interpret results with greater clarity. In our upcoming videos, we will explain all these concepts in detail by using numerical examples. We will carefully discuss some important and representative problems so that each concept becomes clear and easy to understand. This approach will help you develop a strong grasp of the topic and enable you to apply these ideas confidently. Till then, goodbye and have a nice day ahead. Thank you for your time and attention. Thank you.